Hey everyone, you write a Python script, you hit run, and it just works. But have you ever really stopped to think about what's happening in that split second between your click and the result? Well, today we're going to pull back the curtain and explore Python's hidden machinery. It's not magic, even though it feels like it sometimes. It's actually a fascinating journey from the code you write to the instructions your computer understands, and we're going to trace every single step. You see, Python isn't just reading your script one line at a time. Oh no, it's performing this whole complex dance of translation, optimization, and execution, all in the blink of an eye. So let's dive in and see what's really going on. All right, so our journey starts with the very first and maybe the most crucial step, turning the Python code that we can read into a language the computer can actually work with. This is where the magic of compilation really begins. Okay, so first up, meet CPython. This is kind of the star of our show. It's the default, most common Python interpreter out there, and you can think of it as our master translator. Its whole job is to kick off this entire process. So here's how it works. CPython grabs your .py file, reads through it, and then compiles it down into something called bytecode. You can think of bytecode as this perfect intermediate language. It's somewhere between your human-friendly code and the machine's native tongue. And that brings us to bytecode itself, which honestly is like a universal recipe. It's a set of instructions that any computer can understand. It doesn't matter if it's a Mac, Windows, Linux, whatever. This is a huge part of what makes Python so portable. And CPython is pretty smart about this. To save a bunch of time, it tucks this compiled bytecode recipe away in special files that end in .pyc, and you'll find them inside a folder called __pycache __. So yeah, that first time you run a script, it's going to be a little bit slower because it has to do that whole compilation step. But every time after that, way faster because Python just loads the ready-made .pyc file and skips right to the good part. It's a simple trick, but man, it is super effective. All right, so we've got our bytecode recipe. Now, we need a chef to actually cook it. And that, my friends, is where the Python virtual machine, or PVM, comes in. This is the real engine room of Python. The PVM is truly the heart of Python. It's the chef that reads our bytecode recipe and actually carries out the instructions one by one. It's what's known as a stack-based interpreter, which just means it uses a special data structure, a stack, to keep track of what it's doing. Let's see this in action with a super simple example. Just adding two numbers. We're going to watch as the PVM uses its stack, which, yeah, you can totally think of it like a pile of plates, to get the job done. First up, the PVM gets the instruction to load the value of A. It sees that A is 10, and boom, it pushes that 10 right onto the top of the stack, just like putting a plate on top of a pile. Next, it does the exact same thing for B. It finds its value, which is 20, and pushes it right on top. So now we've got 20 sitting on top of the 10. And now for the cool part. The PVM sees the instruction to add, so it keeps the top two values off the stack, the 20 and the 10, adds them together to get 30, and then pushes that single result, 30, back onto the stack. And to finish it off, the PVM stores that result, our 30, in the variable C. The stack is now empty, mission accomplished. Our addition is complete. Now, this whole process might feel like it's happening inside a locked black box, right? But here's the thing. Python actually gives us the key to see inside, and that key is the dis module. Yep, the dis module, it's short for disassemble, is basically like having X-ray vision for your code. It lets you see the exact bytecode instructions that the PVM is going to execute. This is so useful for debugging and just really understanding what your code is doing. And check it out. Here's what its output looks like for that simple addition function. See that? You can see the exact same instructions we just walked through. Load A, load B, add them, and then return the value. It's literally a direct window into the PVM's mind. Okay, so this is all really cool, right? But why does any of this actually matter? I mean, what's the real-world payoff for knowing all this stuff? Well, it all comes down to one word: performance. Let me give you a real-world example. There was this financial analytics firm, and they were really struggling. A critical Python script was running super slow, and it was holding up their entire reporting system. We're talking lost time, lost money. They needed a fix, and they needed it fast. So they used the dis module to analyze the bytecode of that slow function. And what they found was a ton of really expensive, inefficient operations happening over and over again inside a loop. By refactoring the code to reduce those calls, they made a massive difference. And the result? A 35% reduction in execution time. I mean, that is a huge win. And it was only possible because they knew how to look under the hood and diagnose the problem right at the bytecode level. So here's the bottom line. Understanding this whole journey from source code to bytecode isn't just some academic exercise for fun. It is a legit, practical tool that can help you write faster, more efficient Python code, period. So now you have this new superpower, right? You can see the code behind the code. The real question is, what are you going to discover in your own projects? Go out there, explore, and see what you can optimize. You might be really surprised by what you find.